Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 11, 2026, just yesterday. It introduces a challenging new benchmark that reveals a startling gap in modern AI capabilities, finding that even state-of-the-art models like Nano Banana Pro achieve a weighted score of only about 57 out of 100 when tested on fluid reasoning tasks. The paper is titled Genius, Generative Fluid Intelligence Evaluation Suite. And as we'll see later, the diagnostic analysis uncovers exactly why these models struggle and offers a training-free way to improve them. To see exactly what tasks are involved, Figure 1 maps out the benchmark's three main dimensions. The top green section covers implicit pattern induction, where models must deduce unstated rules, like inferring an artist's style from examples. Next, the middle blue section illustrates ad hoc constraint execution, testing arbitrary new rules such as using symbols to change the weather. Finally, the bottom yellow section shows contextual knowledge adaptation, challenging models to ignore priors, like simulating a world with reversed gravity. Well, Table 1 places this new suite in context, comparing it to standard benchmarks like General Eval and Dream Booth. Looking at the central columns, you can see a stark gap. The column for fluid intelligence is filled with crosses for every prior method. This confirms that existing tools mostly test crystallized knowledge, what the model memorized, rather than its ability to adapt. The bottom row highlights that Genius is the first to cover all three dimensions of fluid reasoning, while also supporting complex multi-image inputs. Moving to Table 2, the performance numbers confirm that stark gap. The top section lists proprietary models, where Nano Banana Pro leads with an overall score of just 57.19. The breakdown reveals why. Under implicit pattern induction, this model scores a massive 96 on aesthetic quality, but only 67 on rule compliance. This proves models often prioritize beauty over logic. Finally, the last row labeled Ours shows that the author's intervention improves the open-source Bagel model, boosting it from roughly 27 to 33. Figure 2 analyzes these failures to find the root cause. In Panel A, we see that providing explicit hints helps more than reasoning strategies like pre-planning, especially for the stronger model. Then, Panel B highlights a striking disconnect by comparing comprehension in blue to generation in yellow. Nano Banana Pro understands the rules with 94% accuracy, but only scores 57% when generating images. This proves the bottleneck isn't understanding the task, but a know but cannot draw execution gap. To illustrate the full scope of this benchmark, Figure 5 details the data composition. The inner ring displays the three core dimensions: contextual knowledge adaptation in yellow, ad hoc constraint execution in blue, and implicit pattern induction in green. Moving outward, the chart divides these into broader tasks and finally into 20 specific subtasks on the rim. For instance, the yellow section includes challenges like gravity anomaly and time reversal, which explicitly force the model to defy its learned physics priors. Wrapping up, Genius exposes a critical blind spot in modern multimodal models. They rely too heavily on memorized patterns or crystallized intelligence rather than true fluid reasoning. By introducing tasks that require adapting to novel constraints on the fly, this work pushes the field toward more general-purpose intelligence. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.